Hello, welcome to this 2017 question B3. So we've given the plan and elevation of the display box similar to the one shown here. The design is based on a regular hexagonal pyramid which is truncated as shown. A pictorial view of the box is also shown, so we have this here to help us, which is quite important. Part A, draw the given plan and make a perspective drawing of the box given the following. The spectator S is 1 meter from surface B as shown. The picture plane contains the vertical surface B. Right, that's very important to note. So B is a true shape because you're looking perpendicular to the picture plane in perspective. The horizon line is 1.2 meters above the ground line, and the sloping lines on surface B and C are inclined at an angle of 15 degrees to the horizontal plane. Use an auxiliary vanishing point to determine the sloping line on surface C in the perspective drawn, and then I'll deal with part B, and scale is 1:10. Right, I'm going to pause and I'm going to draw the hexagon. So I'm going to draw the hexagon and the picture plane. The size of it will be 40 millimeters because 0.4 meters in millimeters is 400 divided by 10 gets you 40. So the picture plane is along surface B. So here's the picture plane. Right, the spectator is in the middle, it's in line with the middle, and it's located south in the midpoint of the edge at a distance of 1.1 meter from surface B. So that is 100 mil. Right, now, so to get the vanishing points, we're going to go parallel to two lines. So I'm going to go parallel to S here. There's a vanishing point, VP1. And then here's another vanishing point. I'm going to go parallel to this line. Here's VP2. Now, the horizon line is parallel to the ground line. So straight across, and then it's 1.2 meters above the ground line. So there we go, and I'll just move this over. There we go, we can see that better. Right, surface B is on the picture plane, so I can just bring this down, and because it's on the picture plane, we're going to apply its heights from elevation. So the height of surface B in elevation, according to our drawing, is 90 millimeters. So I can just heavy 90 mil there. And 90 mil there. Now, I'm going to start then doing my perspective drawing after I label this B. So I'm going to bring these 2 points towards the vanishing point on the horizon line. So I need to get my vanishing points down on my horizon line. So I'm going to bring this over here. This one over to here. Now I want where it stops. I'm going to join that point to S. I don't have to join it all the way, but I can if I want. Bring it down, and I'm going to heavy that in there. And now I'm going to join this to VP1 and this to VP1, and I'm going to apply the same idea. Look, I'm going to take the outermost corner, join it to S. Don't have to go all the way, I can just stop there. Bring it down perpendicular. Now, the next thing is going that way, so it's going, this corner is going to VP2, and this one is going to VP1. So I can join this to VP2 on the picture plane. Now, where to get it, I'm going to join the point in plan to S where it hits the picture plane, down perpendicular, So there we go. So I can heavy in this line here. Now, a line parallel to the picture plane in plan is parallel to the horizon line or ground line in perspective. So I can just bring this across. Now when I want to figure out where it stops, it's simply just going to be this point joined to the vanishing point over here. There we go. And can heavy that down. Heavy that in there. Now I can deal with these areas that are sticking up. So it's 0.4 meters above surface B, so 0.9 and 0.4 is 1.3, so 130 mil. Right, now if I want to do this, I need to draw, work from a point that's I have to use a height line. So I'm going to extend this point here. Okay, until it hits the picture plane, down perpendicular. So it should be along this point here. Now I'm going to measure up 130 and it goes to VP1. So I'm going to bring this to VP1. Okay, and now where it hits here, this is the height of the point at the back. Now again, it's parallel to, I'm going to go parallel to the ground line to get the height of this point in perspective, which is this one there I'm referring to. So it's simply this straight up. And now I can join here. Now I have to do the sloping lines. Okay, so the first one on surface A is 0.15 meters up, so 15 mil up from the ground line, and because it's horizontal, it's going to join to the vanishing point 2. And now, oh, that's a little bit inaccurate. Okay, the next one, then the true shape can be, or true angle of 15 degrees can be applied on the front of surface B. Now, I'm just going to pause that and rub it out a bit because that line is too thick. So I can apply the angle of 15 degrees here. Now, the sloping line on surface C, so sloping line on surface C would go to vanishing point 1. Okay, and it makes an angle of 15 degrees with the horizontal plane. So from C to VP1, I need to mark a line at an angle of 15 degrees from the spectator. So 15 degrees from the spectator. So I've done that. And now I need to draw a line perpendicular to VP1 to the line S to VP1 from VP1. It has to be a right angle there. Now there's the true height. So I'm going to take that height with my compass. and I'm going to apply it from VP1. And there's our auxiliary vanishing point. And I can join this to the auxiliary vanishing point and heavy in there. Now, I shall pause the question and darken in all the lines. Right, so that's part A of the question done. Now part B is developments, and so it is. So we have to develop the on a separate diagram surface A, B and C. So on a separate diagram, draw one piece surface development of A, B and C and include the lines on surface A, B and C on the development. So include these. So look, what they're recognizing you, or trying to kind of get you to see, is that any surface on the picture plane is a true shape. So I can take the 40 here for surface B, and suppose I'll do it up here. So there's going to be 1, 2, 3. The heights are the same as what's on the perspective and on elevation, which were 90 millimeters high. So I can mark up 90 mil high. Now, these will be dashed lines here, as they're folded lines. Right, this is surface A, B, C. Now, the height of A, that was 15 millimeters. So I can mark up there 15, and that's a heavy line. Okay, and the angle it said was 15 degrees to the horizontal plane of the line. So I can take my protractor, measure the angle of 15, and essentially just draw through, and that's the question complete. So it is. But there's the development, and there's the perspective image. So cheers, thank you, bye bye.